Welcome to the final stock trading challenge. We are solving LeetCode problem 188, which is titled Best Time to Buy and Sell Stock For. Our primary goal is finding the maximum profit achievable. We can complete at most K total transactions in this scenario. This particular problem is a very common and important interview question. The problem provides us with a list of stock prices, where each price represents a different day. We are also given a maximum number of transactions, denoted by K. A single transaction is defined as one buy action followed by one sell action. It's crucial to remember that you cannot buy a new stock while you are currently holding one. Our task is to determine the best total profit we can possibly make. For our specific example, K is set to 2, meaning we must find the best profit from at most 2 transactions. This problem might initially appear quite complex, but the core idea behind solving it is actually very simple and intuitive. We only need to efficiently track a few key numerical values throughout the process. Specifically, we track the current best cost to buy a stock, and simultaneously, we track the best profit made so far after selling. Since we are allowed K transactions, we will need K distinct pairs of these trackers. Let's refer to them as B1 and P1 for the first transaction, and B2 and P2 for the second transaction, and so on up to K. The B values will track the best remaining money after a buy operation, while the P values will track the best total profit accumulated after a sell operation. We will systematically process the stock prices one day at a time, iterating through the entire list. For each day's price, we will ask 2 critical questions for each allowed transaction. First, what is the best possible cost to buy the stock at this point? We update B1 by comparing its current value to the negative of the current price, as buying represents an outflow of money. Second, what is the best profit we can make right now, considering a potential sell? We update P1 by comparing its current value to the profit derived from selling today, which is the current price minus our best buy cost. For subsequent transactions, such as B2 and P2, the cost for B2 is calculated using the previous profit P1, because the money from the first transaction's profit is now available for the second buy. This precise pattern of comparing and updating repeats for all K transactions. Let's trace our example with K equals 2 to see this in action. On day 1, the stock price is 3. We update B1 to -3, reflecting the cost of buying. Our profit P1 remains 0. All other variables, B2 and P2, are also unchanged at this point. On day 2, the price drops to 2. We update B1 again. It becomes -2, representing a better buy cost. Now we update P1. Selling for 2 after buying for -3 would give a profit of 5. The new P1 is 5. This process ensures we always capture the maximum profit for the first transaction up to this day. By diligently repeating this simple compare and update process for every day and every transaction, we effectively consider every possible buying and selling opportunity. The tracking variables are continuously updated to always hold the absolute maximum profit or minimum cost for each step. The final answer to the problem is simply the maximum profit stored in our last variable, which is P_K. In our specific example, with K equals 2, the final maximum profit will be found in P2, which ultimately reaches 7. That encapsulates the entire conceptual idea behind solving this problem. The actual code implementation is surprisingly clean and elegant. Click to watch part 2 for a direct Python implementation and detailed code explanation.